This lesson helps you understand relations, the domain and range of relations, and how to determine when relations are functions. In algebra, a relation is just what the word means, a relationship between a set of input values and a set of output values. For example, if you make $25 an hour working 4 to 8 hours a day, there's a relationship between the hours you work and the amount of your pay. For this relation, if you input 4 hours, the output is $100. If you input 5 hours, the output is $125, and so on. The most basic way to represent a relation is with a set of pairs of numbers, x and y. The variables x and y are commonly used to refer to the first and second numbers of each pair. There's usually a rule that defines the relationship between the first and second number of each pair. In this case, the second number is 1/2 of the first number. For example, if you input x equals 4, the output is y equals 1/2 times 4 equals 2. So for an input x equals 4, there's an output y equals 2. These pairs of numbers are called ordered pairs because the order matters. The first number is the input x value, and the second number is the output y value. In addition, the x variable is called the independent variable, and the y variable is called the dependent variable. These names are used because the value of y depends upon the value of x. The set of all input x values is the domain of the relation, and the set of all output y values is the range of the relation. Given any relation, you need to be able to identify its domain and range. Another way to represent a relation is with a mapping diagram. In a mapping diagram, the domain is shown on the left, and the range is shown on the right. Arrows show how each element of the domain is related to elements in the range. For example, if the ordered pair 4, 2 is part of the relation, there's an arrow between 4 in the domain and 2 in the range. You can organize the list of ordered pairs in a table. This makes it easy to represent the relation with a graph. Returning to the mapping diagram, this relation is a function. When each element in the domain maps to one element in the range, the relation is a function. Here's an example of a relation that's not a function. Notice the input value x equals 2 maps to two output values, y equals 1 and y equals 2. Also, x equals 4 maps to y equals 3 and y equals 4. When elements in the domain map to more than one element in the range, the relation is not a function. A graph of the relation makes it easy to see that it's not a function using the vertical line test. If any vertical line passes through more than one point on the graph, then for one value of x, there's more than one value of y, and the relation is not a function. Notice this relation fails the vertical line test at x equal 2 and at x equal 4. Since this relation fails the vertical line test, it's not a function. Here's an example of a relation that passes the vertical line test. No matter where you draw a vertical line, it passes through only one point on the graph. Since this relation passes the vertical line test, it is a function. This relation is also a function, but it can be a little confusing because two elements in the domain map to one element in the range. It's still a function, however, because 2 maps only to 2, and 4 maps only to 2. That they both map to the same element doesn't matter. If you graph the relation, you can see that both of these points have the same y value, and both of these points have the same y value. However, it passes the vertical line test. And it is a function. This lesson helped you understand relations and functions. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.